Welcome back to our lesson. We're still looking into internal resistance. So before the break, what we did, we managed to look at the concept of what exactly internal resistance is. So this is the resistance inside the battery. But then remember, we cannot see the resistor inside the battery. Hence, the term suggests that it's internal. But there is a way of actually measuring, or determining internal resistance that is inside the battery. But keep in mind that the resistance or the resistor inside the battery is actually in series with the resistors that are in the external circuit. Hence, we said if we are to determine the total resistance in a circuit, we would actually add the big R and the small r because they're actually in series, because the same amount of current that goes through the battery, which goes through the internal resistor, is equal to the current that goes through, to the external circuit. Now, let's look at how exactly we're going to achieve that. Right, so the big question now in this segment is around how can we find the internal resistance of the battery. So now we are interested in actually quantifying or determining the internal resistance, right? Okay, so lost volts, remember we say the volts are actually not exactly lost, okay? They are not lost in the sense that voltage has to do with work or energy done, or energy, per coulomb of charge. So we know that energy cannot be lost per se. We are saying that the lost volts are actually not available for the external circuit. Hence, we would use the term lost volts. The same implies, I think we can use the term V internal instead of lost volts to refer to one and the same thing. Right, so the term lost volts is actually the difference, okay, between the EMF and the terminal voltage in a closed circuit. Take note, if we are to measure voltage across the source while the switch is open or while there is no current in the circuit, that measurement gives us the EMF reading. Okay, so be careful. EMF reading and EMF are two different things. Yes, they talk about the same quantity, but the reading is what we practically obtain when we connect, a voltmeter across the ends of a battery or a source while the switch is open or while there is zero current. While, the V load is actually when we close the switch and then we measure the terminal potential difference. Right. So we know that the EMF is the maximum, energy per coulomb of charge that can be dissipated by the battery. So this is the same as, in other words, we are saying E is equals to V external, okay, plus V internal. Oh, this is the lost volts, all right? So these are our lost volts. Take note. So we'll use V lost and V internal interchangeably to refer to that difference between external, EMF and V external, right? Okay, this gives us what? Lost volts. Okay, take note of that. Okay, so if we, this is our lost volt, and then that's our EMF, and then that's our V load or V external. So this is V internal, okay? This is our EMF, which is the maximum, and then this is the V load. Okay, take note of that. Okay, and then we are saying, how can we calculate or measure? Okay, if we calculate, we are using an equation. Okay, so this one is used by use of an equation. Okay, and then the equation that we're talking about here is the equation E is equals to I, okay, R plus R. Okay. Then if we measure, we are actually using a voltmeter to actually get the difference between the voltage across the source while the switch is open and while the switch is closed. Okay, so we'll measure terminal voltage, in an open circuit. This will give us what? The EMF, right? While in a closed circuit, this will give us the V external. We need just to be very clear on that. Then we can measure the current through the battery, right? So the calculation is based on this equation. So the equation, we're only going to use it if there's only one unknown, okay? So we might have current, the EMF, the external, resistance, and then the small r being the only unknown. So we are able to actually do that. So in this case, the switch is open or the circuit is broken. Okay, take note of that, right? So that EMF reading the 18 volts is equals to our EMF reading, okay? Then the current is 0, which means this is the EMF reading because this is the potential difference across the source while there is no current in the circuit, okay? And then once we close or complete the circuit, we know that our E from the previous reading is 18 volts, okay? And then the total current or the main current in the circuit is 1,12 amperes. Okay, but then what is this 6,75 volts? This is actually V load, okay, or our V external. In other words, this is of the 18 volts, only 6,75 volts is available in the external circuit. It means the difference between 18 and 6,75 actually gives us the lost volts. So this is equals to 6,75 volts. Right, then what are we looking for? We are looking for the internal resistance, right? Now, we've got the current. Now, each time there is a problem that is centered around the calculation, you must be able to use the data sheet correctly, copy the formula as it is given, do the necessary substitution, and get the final value or the answer with the correct SI unit. That's very, very important. So typically these questions will be 3 or 4 marks. So it's formula, substitution, correct answer, including the correct SI unit. So in this case, if we are to calculate the internal resistance, we are able to say, okay, the current that we have in this case is 1,12, okay? So now we're doing the substitution, okay? We don't know internal resistance is equals to 18, okay? Minus 1,12, okay? But this, be careful, this is the 6,75, which is the V load, okay? So we can go directly and say 6,75, okay? 6,75. Then we are able to find the internal resistance of this battery, okay? Now, if we can quickly go to our calculator, just to verify that. So it's going to be 18 minus 6,75, okay? 6,75. Okay, so this value that we obtained here is actually the lost volts, right? So it's 11,25. We need to divide it by the current so that we make R the subject. So our current is 1,12, okay? 1,12, okay? What do we get? So in this case, our internal resistance is 10,04 ohms, okay? So it's 10,04 ohms. So that's how we use the measurement and the calculations to actually determine the internal resistance of a battery, okay? Okay, good people, we'll take a short break for now, and then we'll take our discussions after the short breather. Let's take a break.